In this video, we're going to focus on how to find the nth term for an arithmetic or geometric sequence. So let's say if we have these numbers, 3, 7, 11, 15, and so forth. And let's say you want to find the 10th term of the sequence. How would you do it? Well, a quick and simple way is you can see the common difference is 4. 7 minus 3 is 4, 11 minus 7 is 4. So we have an arithmetic sequence. So the next number after 15 has to be 19th, that's the 5th term, and then 23rd, the 6th, 27th is the 7th, and then 31 is the next one. That's the 8th, 35th, and 39th is the 10th term. So because the 10th term is not too far away, it's easier if we just write out the sequence and find it. It's actually faster doing it that way. But let's say if you want to find the 40th term or the 100th term. Now, you don't want to write out 100 numbers. That's going to take too long. So what you want to do is you want to use an equation. So first you want to write an explicit formula that explains these patterns of numbers. So you need to use this equation. A of n is equal to a of 1 plus n minus 1 times the common difference. The first term, that's a of 1, which is 3, and the common difference is 4. So distribute 4 to n minus 1. So you're going to get 4n minus 4, and then combine like terms. Combine the 3 and a negative 4. So 3 minus 4 is negative 1. So this is the general equation that you need. So now if we plug in 10 for n, it's going to be 4 times 10 minus 1. 4 times 10 is 40, and 40 minus 1 is 39, which we indeed get this number. So if we want to find, let's say, the 40th term, just plug in 40 for n. So 4 times 40 minus 1. So 4 times 40 is 160, and 160 minus 1, well, that's 159. Now let's say if, well, here's our second problem, 2, 6, 12, dot, dot, dot. So notice that this is not an arithmetic sequence. If we were to look for the common difference, if we subtract the second term by the first term, 6 minus 2 is 4. It is not the same as the third term minus the second, because 12 minus 6 is 6. So therefore, this is not an arithmetic sequence. Now, if we divide the second by the first term, we can see that 6 divided by 2 is 3. And you know what? Let's make this 18 so that it works for a geometric sequence. So 18 divided by 6 is 3. If we were to do 18 minus 6, that would be 12, and it still wouldn't be an arithmetic sequence. But I wanted this to be a geometric sequence. But now it is. Before it wasn't. But with the 18 now it's geometric. Because 2 times 3 is 6. That's the common ratio. And 3 times 6 is 18. So now what you want to do is, let's say if you want to find the 12th term. You can keep multiplying by 3 if you want, but that's going to take a while unless you have a calculator. But let's use the formula to get this one. The formula that we need is a of n is equal to a of 1 times r raised to the n minus 1. So plug in the first term, which is 2, and replace r with a common ratio. So that's the general equation. So to find the 12th term, plug in 12 for n. So 12 minus 1 is 11. And we need to figure out what 3 to the 11th power is. So I don't think you want to multiply 3 11 times. So you want to use a calculator. 3 raised to the 11th power is 177,147. And then multiply that by 2. So then the 12th term is 354,294. It's very big. Now what about this problem? So let's say if you have 3 over 2, 8 over 4, 13 over 8, and 18 over 16. So how can you find the 9th term of this sequence? How would you do it? So feel free to pause the video and see if you can figure out this problem. And then unpause it when you're ready. So when you have a fraction, separate the numerator from the denominator. Notice that the numerator is an arithmetic sequence. The common difference is 5. 3 plus 5 is 8, 8 plus 5 is 13, 13 plus 5 is 18. So you want to write an equation just using that pattern of numbers. So the first term of that sequence is 3, and the common difference is 5. So distribute the 5. So a of n is going to be 3 plus 5n minus 5, which is the same as 5n minus 2. So we're going to save that. Now, if we look at the numbers on the bottom, 2, 4, 8, 16, notice that it's a geometric sequence with a common ratio of 2. 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So now we're going to use the general equation for a geometric sequence. So it's a of 1 times r raised to the n minus 1. So the first term is 2, the common ratio is also 2, raised to the n minus 1. Because the bases are the same, we can add the exponents. For example, x squared times x to the third is x to the fifth. 2 plus 3 is 5. We can only do that because the base x is identical. Now, because the base 2 is identical, 1 plus n minus 1 is just n, because 1 plus negative 1 is 0. So therefore, this pattern of numbers can be explained by 2 to the n. If you plug in 1 for n, 2 to the first power is 2. 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16. So now we got to write an equation for these numbers here. So we're going to combine these two into one equation. So let's see where I can fit this. A of n, I meant to put that here, is equal to 5n minus 2, which is for the numerator, divided by 2 raised to the n, which is for the denominator. So we want to find a of 9. So that's equal to 5 times 9 minus 2 raised to 2 to the 9th power. So 5 times 9 is 45, and 45 minus 2 is 43. And if you use your calculator, 2 raised to the 9th power is 512. So the 9th term is 43 over 512. And that's how you can figure it out. Another way you can do this is, for the numerator, you can keep adding 5 until you reach your 9th term. So 18 plus 5, that's 23, that's the 5th term. The 28 will be the 6th term, 33 will be the 7th, 38 will be the 8th, and then 43 will be the 9th. For the bottom numbers, keep multiplying by 2. The 5th term for the bottom will be 32, the 6th would be 64, the 7th would be 128, the 8th would be 256, and the 9th will be 512. So you can do this intuitively if you want, if you feel that that's going to be faster. And actually, I think that that method is actually quicker because it doesn't take long to reach the 9th term. But if you want to find like the 40th term of the sequence, it's best to use the equations that we discussed here. So you got to choose which method is better, just to continue the sequence or to find an equation and plug in the nth term. But now, let's say if you get a question that looks like this. Let's say if the first term is 5 and the fourth term is 14th. How can you find the 27th term? And let's say that you're told that this is an arithmetic sequence. How would you figure this out? For this one, you have to know if it's arithmetic or geometric. So, since it's arithmetic, to get the second term, we need to add the common difference. To get the third term, we need to add the common difference. And to get the fourth term, we got to add d again. So to go from a of 1 to a of 4, we need to add 3 common differences. So a of 1 plus 3d is equal to a of 4. Notice that the difference between 4 and 1 is this number 3. So let's say if I have the value of a of 5 and a of 12. The difference of 5 and 12 is 7, so a of 5 plus 7d is going to give me a of 12. Makes sense, right? 12 minus 5 is 7. So now let's solve for the common difference. So the first term is 5, and the fourth term is 14. So 14 minus 5 is 9, and if you divide both sides by 3, d is equal to 3. So now that you have the common difference, what you can do is write a general equation. So a of n is equal to a of 1 plus n minus 1 times d. So the first term is 5, and the common difference is 3. So if we distribute the 3, we're going to get 3n minus 3. So 5 minus 3 is 2. So the general equation is 3n plus 2. If we plug in 4, 3 times 4 is 12. 12 plus 2 is 14. So this equation works. So now let's find the 27th term. So that's 3 times 27 plus 2. So 3 times 27 is the same as 3 times 20 plus 7. 3 times 20 is 60, and 3 times 7 is 21. 60 plus 21 is 81. So 81 plus 2, that's 83. So that's the 27th term. So now let's try another example like this, but using a geometric sequence. So let's say the first term is 24, and the fourth term is 3. So to go from a1 to a2, we need to multiply by the common ratio. To go from a2 to a3, we need another common ratio. And from a3 to a4, we need another one. So if it was an arithmetic sequence, it would be a1 plus 3d is equal to a4. With arithmetic sequences, you're adding and subtracting. If d is positive, you're adding. If d is negative, you're subtracting. For for geometric sequences, you're dealing with multiplication and division. So here, to go from a1 to a4, you need to multiply a1 by 3r instead of adding a1 by 3d. You can still use these techniques though. The difference between 4 and 1 is 3. So that's how you get that number. So the first term is 24, and the fourth term is 3. So we're going to divide both sides by 24. Actually, hold on. I need to fix this. This is supposed to be r times r times r, which is r to the third power, not 3r. So this is r cubed. So the 3 should be in the exponent position. So the first term is 24 times r cubed, which equals the fourth term, which is 3. So we're going to divide both sides by 24. So if you divide it backwards, 24 divided by 3 is 8. So we get 1 over 8. So now what you want to do is take the cube root of both sides. So r, therefore, is the cube root of 1 over 8. The cube root of 1 is 1, and the cube root of 8 is 2, because 2 times 2 times 2 is 8. So the common ratio, therefore, is a half. So now what you want to do is write a general equation. Well, by the way, our goal for this problem, let's say we want to find the 10th term. So a of n is equal to the first term, which is 24, times the common ratio raised to the n minus 1. Now that we have a general equation, let's plug in 10 for n. So 24 times 1 half raised to the 10 minus 1, which is 9. So now, in your calculator, just type in 24 divided by 2 to the 9th power. And my calculator is messed up. I got to do this by hand. So let's do this without a calculator. So I have 9 2's, but I'm going to use just 6 of them right now. I mean just 3 of them. 24 divided by 2 is 12, so that gets rid of that 2. And 12 divided by 2 is 6, and 6 divided by 2 is 3. So what I basically did is 24, it's basically 8 times 3. And 2 to the third is 8, and we have a 2 to the 6 left over. So we have a total of 9 2's on the bottom. So pretty much I split it. So 8 cancels with 2 to the third because they equal the same thing. And 2 to the 6, that is 64 if you type it in your calculator. So the final answer for this whole problem is 3 over 64. So that's pretty much it for finding the nth term of an arithmetic or geometric sequence. So depending on if you have a sequence or if they give you two terms, just use what we did, just follow the same steps, and you should be okay on your test. So that's it for this video. Thanks for watching and have a great day.